Hello, math scholars, coming at you with another math video. Mrs. Harp here. Today we're learning 6.3 day 1. We're going to learn a little bit about normal distributions and means and variance and standard deviation. Lots of fun stuff. So please have your calculator out. Please be taking notes along with me. At any time, if I go too fast, just click pause and maybe even rewind and allow yourself to catch up. Okay? Here goes. So let's start with the word mean. You're probably familiar with mean. It's really just an average. To find your mean, you would add up all your numbers on your list and divide by n, which is the number of data on your list. So if you'd have 5 numbers, you would add them up, click enter, and then divide by 5. The shorthand way of writing mean is x with a bar on top. So if you ever see that in the book or in my notes, you will know that that means mean. Variance can be written with a Greek letter called sigma. That's what you're seeing over here on the right. Variance is the average of the squared differences from the mean. So that will make more sense when we do an example problem, but basically you would find the average of your data set, and then every single number you would see how far it is from the average. That's called a deviation. You would square that number, add it up, and average it again, and that's going to be your variance. I kind of said that wrong. You add it all up. Yeah, add it all up and average it. That is your variance. I said that correctly. Yep. And standard deviation, that's a word that you might have heard of before. Standard deviation then would just be the square root of the variance. It's a measure of how spread out the numbers are, how close the numbers are to the mean. It's denoted by the Greek letter sigma. So you can click pause if you need more writing time, but I am going to go on to our first example about sunflowers. All right, so below are the heights of my sunflowers last summer. Let's see how many sunflowers I grew. 1, 2, 3, 4, 5, 6. That means my n value is 6. That's the number of sunflowers I grew this year. So we're going to go ahead and find the mean. So we're going to average these numbers up. Grab your calculator. I'm going to calculate right along with you. 8 plus 14 plus 16 plus 14 plus 24 plus 20. It's very important for you to click enter right now to get that total. So the total I have on my screen is a 96. You'll go ahead and divide by 6 because that's the number of sunflowers I grew. And that'll give you a mean or an average of 16. All right, hopefully we're doing okay then. So what we're going to do next is try to calculate the variance. To calculate the variance, we're going to find out how far off the mean each of my numbers on my chart are. So I will call this the deviation. It's not the standard deviation, it's just the deviation, how far this number is from average. So this number 8 here is 8 below average. So I'll go ahead and put an 8 here. It doesn't matter that if it's below or above, you can just go with a positive number. 14 is 2 away from the average, so you just put a 2 here. 16 is right on the average, so you put a 0 here. 14 is 2 below. 24 is 8 above. And 20 is 4 above. Give myself a little more workspace. All right, what you're going to want to do now in this third column is square your deviation number. So square of deviation number. In other words, 8 squared is 64. And that's why it really didn't matter if I put a -8 or a +8 there, because you end up squaring it. So it's a positive 64 regardless. 2 squared would be 4. 0 squared is 0. 2 squared is 4. 8 squared is 64. And 4 squared is 16. What we're going to do is total up that column. We're going to find the sum of that column. This letter here is also a Greek letter, and it can denote sum. So if you ever see me write that, it just means I am summing something up, adding something up. So let's go ahead and add up that square of the deviation column. 64 plus 4 plus 0 plus 4 plus 64 plus 16 gives me a sum of 152. Now it's our goal to average this, to find the average of the squares of the deviations of our data set. So I will take that 152 and divide by 6 and get 25.3. That's going to be our variance, or sigma squared, in other words. That's what variance is. And if you go back to our definition of variance, it was the average of the squared differences from the mean. So I should almost call this difference in square of difference rather than using that word deviation, but it's okay. Now to find the standard deviation, sigma, you simply square root your variance. So square root the number 25.3, and that'll give you what your standard deviation is. So square root 25.3. I'll go ahead and do that. 5.03. And you end up using that number for a lot of things. So it's very important that you know how to find that number. It's called a standard deviation. Okay? I know it's a lot. Hopefully you're sticking with me. It's not more than easy, simple calculations and averages, though. We're going to do our next example is going to be an example about cats. That'll be fun. Go ahead and click pause if you need more time to write. Alright, you're back. So I've got a lot of cats, and these are the ages of my cats. Let's see how many cats I have. 1, 2, 3, 4, 5, 6, 7. I've got myself 7 cats, so my n value is a 7. I wanted to write n equals 7, but my smartboard's not behaving up there, so I'll just write it over here. My n value is 7. That's how many cats I have. That's the number I'll be dividing by a couple times today. Let's go ahead and find the average age of my cats. So here goes nothing. 5 plus 10 plus 8 plus 7 plus 1 plus 17 plus 15. Click enter. That gives you 63. And divide by 7, because that's how many cats I've got. My average, or my mean, for my ages of my cats is 9. So if you remember right, we're going to make ourselves 2 columns. This column will be the difference from the mean to the age of the individual cats, and this one would be the square of the difference. Sorry, my smartboard alignment is just not the best at the top of the board. So the first column is the difference from the age of the cat to the mean, and the second column is the square of that difference. Alright, so this cat is 5 years old. He is 4 years younger than the average of 9 years old. So that would be a 4. This cat is 10 years old, so he's only 1 year off the average age. The 8-year-old cat would be 1 year below the average age of 9. 7 is 2 years off the average. A 1-year-old cat would be 8 years off the average, below the average. A 17-year-old cat is also 8 years off the average. And a 15-year-old cat is 6 years off the average. All right, so my second column is done. I don't need to average that column. What I need to do is square those numbers. So to get your third column, Go ahead and square all the numbers in your second column. So 16, 1, 1, 4, 64, 64, and 36. That's the column we're going to want to go ahead and average. And when we find that number, it will be our variance. Okay? Again, click pause at any time if I'm just going too fast for you, okay? 16 plus 1 plus 1 plus 4 plus 64 plus 64 plus 36. Click enter. That gave me a sum of 186 that I would want to go ahead and divide by 7. I have 7 cats. So it's 26.57. That's our variance. When you square root that number, you'll get your standard deviation of 5.15. So we'll be doing a project here in a couple of days where you'll be surveying classmates, and this is exactly the type of calculations you'll be doing: finding the average, finding the variance, finding the standard deviation, and putting that data to a chart. All right, hopefully you're doing well still. Let's jump ahead to something called the normal curve. All right, so you will be receiving the normal curve on a little strip of paper. You can put it in your binder, tape it in, do whatever with it. But it's a very important chart that you would be given on all quizzes and tests. It helps find the probability that a given result would be a certain amount of distance from average, okay? All right, so I want to point out a few key features of this little normal curve you're seeing here. I don't really use the one on the left. I really use a lot the one on the right. So here's a few key features. X bar would be your mean. So that's going to be smack dab in the middle. So basically, you would have a 50% chance of being below that, or you'd have a 50% chance of being above that. You would add up all those areas, the percentages in the different areas. Then we just kind of go one deviation above, one standard deviation above for this line, 2 standard deviations above for this line, 3 standard deviations above for that line, and then below. So basically you'll be just finding different probabilities based on the different areas that you're seeing on this picture. This will make more sense when we actually look at a problem. Let's look at our a blood cholesterol problem here. The blood cholesterol readings for a group of women are normally distributed with an average of 172. What I would do with that number right about now is put that 172 right here in the center. That's where your average number goes. It has a standard deviation of 14. That's going to allow us to put the other numbers onto this chart. So my line that's one slot to the right would be 1 deviation to the right. So I would take the 172 and add a 14 to it. That would be a 186. I would add another 14 to go one more standard deviation to the right. That would be a 200. And I would add another 14 to get that last little line, and it's 214. Now let's work our other direction from 172. Go back to the middle where the 172 is and subtract off 14 to go 1 standard deviation to the left. It would be 158. Subtract off another standard deviation, that would be at 144. And subtract off one last standard deviation of 14 to get to the 130. Now I'm going to explain how this is going to work to answer different questions. When they ask the question, what percent of women have readings between 158 and 186, you will be identifying those areas on your curve and adding up the percentages. So let me go ahead and circle that. I'll maybe use my green pen here. I'm going to circle all the areas between 158 and 186. And if you look closely, that's those two purple areas. So I would end up adding 34% and 34%, which means like 68% of women would have readings in that area. Okay? The next question says, readings less than 158 are considered desirable. What percentage of readings are desirable? So we're going to look at the area under the curve in this space. Readings less than 158 would be right about here where I'm circling in black. So you want to add up the percentages in those areas. So we have 0.15 that we will add together with 2.35 that we will add together with 13.5. So it's 16%. 16% of women would be in that desirable area. All right. Let's look at our next question. It's also a question based off of the curve, and so it's asking about areas and stuff. It says a normal distribution has an average mean, x bar, and a standard deviation, sigma. For a randomly selected x value from the distribution, find this probability. So let me explain what they're asking. This right here would basically be saying go 2 standard deviations below the mean. So I'm going to circle that right here. That would be this line. Find the probability that we are between there and the mean. So we want the probability that our x value will fall between this pink line and this pink line. We're basically going to add up these percentages. So 13.5% and 35%. Or sorry, 34%. So 47.5%. So it's really hard because I can't look out in the audience right now and be like, how are we doing with this? How are we doing with this? But not the easiest lesson to do with a video. So if you have confusion, no panicking. I'll try to clear up everything when I'm back tomorrow. I had a meeting today. So thanks for being patient. Thanks for following along with the video. And do the best you can with attempting the worksheet. And if you have questions, I totally understand that, and we'll try to clear up the confusion tomorrow. Okay? Bye-bye.